Hi everyone, I'm Kaveri and welcome back to my YouTube channel. So today I'm going to give a quick overview of the Android's architecture and show the difference between the static and dynamic pen testing. So first I will explain what is Android. So in this core layer, then I will cover the two testing approaches, that is common tools we use and typically find from each. So finally a short conclusion and what the next step. So let's move on the video. So let's move to the first video, that is talking about Android architecture stack. So Android is an firstly say about like Android is a mobile OS like built in the Linux kernel. So it organized in the layers. So each layer it is a 4 layer. So I mentioned here 5 layer because typically we can find in the online about the 5 layers. So basically we can talk about the 4 layers. So it's handle other things. So first layer, like the bottom layer is Linux kernel and the hardware abstraction layer is topmost, and the native libraries in the ART and application framework and application. So these are the 5 layers we can see. So for easy understanding, I am going to throw this website showing about this Linux kernel. And so in this layer we can able to see the 4 main layers, that is Linux kernel. So Linux kernel is the bottom layer, we can say the heart of this heart of the Android, that controlling how the software talks to the hardware. So it manages the device drives like the camera drivers, Wi-Fi drivers, Bluetooth drivers and display drivers we can see here. So it also handles the security process management and the memory control. For example, we can say that when we tap the camera button to take the photo, the kernel communicates with the camera hardware and tells to capture the image. So this is what happened in the Linux kernel. So let's move to the next layer, that is library and ART, that is means like Android runtime. So libraries means like this layer has two parts. So libraries means like these are the pre-written like C or C++ code component that make the app run faster. Sorry for the background noises. And in this is we can see OpenGL, so which means that handle the graphics, SQLites which manage the database, media framework, process or like the process audio and the video, SSL and WebKit means like handle the web connections and securities. So these are the things we can able to see in the libraries. And when we move to the Android runtime, we can there is an app actually run. So this is the place where the app run. So it convert the app's code like written in the Java or Kotlin into the machine code. So that's the phone hardware understand. And each app run in their own sandbox, which means it's isolated for the security. And so when we connect with that example before said, like when a camera app run, the runtime execute the app code and use the libraries and process the stored photo effectively. And now the third, that is application framework. So it is like the main brain of the Android, that it manage how the app work together and interact with the system. So it provides the ready-made API like application programming interface for the developers. Important components it's contain like activity manager, window manager, notification manager, camera manager. Like activity manager controls the app screen, window manager that handle what visible on the screen, notification that show the alert and notifications, and camera manager give the camera access to the app. So these are the main things we can able to find. So the example, like after the photo we capture, the framework media store API save the image and show the notification like the photo saved to gallery. So and we are going to this for a top layer, that is application, and that is this layer we see the interact with like the system app like a camera, contact settings, and there will be third party application like the WhatsApp, Instagram kind of things. So what we see when we open the gallery app, it uses a framework API to fetch and display the photo that's saved earlier. So in short we can able to say that the camera app, that is application, use the framework API which talk about the libraries and runtime and which communicate with the kernel drivers and which control the hardware. So this is what all about this architecture. So next we can move to the static and dynamic analysis. So these are the two types of Android pen testing, that is static analysis, which we are analyzing before the running app, and dynamic analysis, which we are analyzing while the app is running. So static analysis means like checking the APK code, manifest, permission and logic. And dynamic means like observing the app's behavior run on the network requests and runtime changes. So the static analysis means like insert the app without running it, like APK, manifest, code, resources. And dynamic analysis means like observe and modify the app while it runs, like the network, storage and the processes, runtime, hooks, like this. So we can move to the static analysis deep observation, that is talking. So yeah, this image, yeah. So static analysis. So the static analysis means like what we do, means like unpack or decompile the APK, that is Apktool or Jadx, and read. So Android manifest.xml, which is the main thing, that blueprint we found of the app. So which contain the exporter component and permission, network config, and the decompile Java mail, which contain the logic, hardcoded string, API endpoint, and resources and asset like configure the file, proto, JSON, and AT libraries and certificate. And also automated scan with the MobSF, that is one of the tool, or we have the Jadx and strings to scan to flag the obvious issues. And we can able to find the hardcoded key, the insecure configuration, explore the components, suspicious libraries, weak crypto usage, debug flag, and embed a secret from this. So this is what the static analysis means, like what the things we are finding, typically finding it out. And with the benefit is like a safe and repeatable, no need to run the on device, safe for the CA integration, and faster for mapping, comprehensive code visibility, automation friendly. But there is some limitations also, that is maybe there is false negative, obfuscation native code, and non-time trained behavior, and static assumption. So this is what we can get and understand about the static analysis deep dive. And next move to dynamic analysis. So dynamic analysis in action. So dynamic analysis means like what we do, means like app that run an app on emulator or the device routed or instrumentated, interact the trigger flow and observe, intercept the network, like we can use the Burp Suite or the Zap or any kind of things that can able to, like MIT, like there is a called MITM proxy. So request, header, cookies and talker. Then hook time runner, like which means like Frida or objection. So bypass the pinning, dump memories and insert the arc. Then we can like insert the app storage, like the data, PKG, and the shared preference database files. And we can able to monitor the log, process memory, native call if needed. So deep link will be there, and the content provided. And also in the static we can able to find the deep link and kind of things in the intended filters. So by using the dynamics, we can see how the app behave in the real server, token and dynamic data, confirm that the static hypothesis, and explore the runtime logic flows, like the authentication bypass, token replay, insecure storage, scenes live. And in the common tools we have been using in this, it's about the Frida, like ADB, Burp, Frida plus server, objection, MITM proxy, Jadx for the like reference. And there are some more things we have to do understand. And okay, then we can also talk about the benefit, like real-time behavior. It is one of the most things we can talk, that is the disadvantage in the static analysis. So it reveals the actual traffic, like the runtime keys and server responses, and exploit the validation, which proves whether a static finding is exploitable. And advanced testing, which means they can bypass the protection, manipulate the memory and confirm the logic, and catch the environment dependent bugs. So there are some limitations also we can find, that is risky or destructive, which means like running a test can able to crash the app or affect the backend, must have any permission or authorization, and require setup. That's other thing, that means like the router device has special configuration for full visibility, like Frida server proxy cert. And next is evaluation, like app may be detect the instrumentation like anti Frida or the harder native code making hook harder. And also there is harder to scale, which means like manual step and content need to like each app flow. So just a practical tip means like start with a non-destructive observation like a passive proxy logcat, then execute to hook and only if the confirm with the test scope and permission. So if you are doing pen testing, we have to start with the static, that the map the attack surface, list the likely target, and then dynamic, that the validate and expose the promising finding like the network running time and storage, and then when tight on the time, like the static gives quick high level coverage and dynamic give the definitive proof and impact. So these are the things we have to talk about in the dynamic analysis and automated static scan. So this is means like a next actionable step, that is automated static scan trigger the prioritize and target the dynamic tests. And remember that static and dynamic method work together, and static analysis map the terrain and dynamic analysis validate the path, and always test it with the proper authentication and follow responsible disclosure practices and this content in the ethical way. So please take it as an ethical way for educational purposes only. So and these are the things I had to teach in today's video, all about the Android and how the pen test, like the two types of things. And I hope you understand all about these topics and things. So let's see in the next video, hoping a safe things, and see you in the next video. Bye bye.